Just casually letting you know that I'm famous.
What?
Daily quiz, do the thing.
Congratulations to the knowledgeable team for first place finish at the Douglas meet. Members of the winning team are Greg Whiteford, Sam King, Bruce Williams, Owen Whiteberg, and Hunter. For those interested in going on the French trip this March, there will be an informational meeting Thursday, September 30th at 5:30. All parents and students are encouraged to attend. It is not mandatory, however, if you are already planning the French trip. Only those who are interested in going can. If you have any other questions, please see the classroom. Congratulations to the Spearfish High School Marching Band. The Black Hills State University Alumni Association named your band the 2021 Swan Day Top Band of the Day. This honor and recognition carries $1,000 prize. GFA is leading this Wednesday for lunch in Mrs. Nenet's room. E-Club members, Thursday, September 30th, during lunch in the auxiliary gym. Pizza will be provided. All juniors and seniors with a GPA of 3.55 or higher are invited to apply for the National Honor Society. Those students who have met the GPA requirement should check their email applications for materials. The deadline to apply, October 15th. Any senior student interested in serving as a legislative page, your information is in your email. If you have any further questions, please see Mr. Morford. A reminder, there is no school on Friday. May I please have your stand for the
United States of America, and to the republic for which it stands, one nation, under God, indivisible, with liberty and justice for all.
You had a calculator, try it. Did your child also wake up laughing maniacally at 4 a.m.?
Laughing?
Uh-huh.
Scared or something?
No, he pooped. We wake up at 4 a.m. to over the monitor. So. Do the thing. It's almost like repetitive behavior and speech patterns is indicative of the autistic spectrum.
I say the same thing to all my customers.
Anyone still rolling? Okay. There you are. Replace f of x with y and then swap them. Most people are okay with going straight here. And having done about 6 or 7 of these now, I think we're okay with the trick, which isn't really a trick, it's just math. Cross multiply. We say y is 2xy minus x. Get the y stuff on one side. Say y minus 2yx is negative x. Factor out your y. And say 1 minus 2x, negative x. Divide. And you actually have a choice. You can leave this as inverse function of x, negative x over 1 minus 2x. That is still technically correct. Or most folks are going to say multiply top and bottom by negative 1. Like that. It's the same thing. Okay. And domain, who's not allowed to that after party? Okay. Set the denominator equal to 0. Thou shalt not divide by 0. And 1/2 is the gap in the range for the original function, so that is correct. So, domain, wording matters. The domain, not the restriction to the domain. So I will actually say negative infinity to 1/2, can't touch a span, and 1/2 to infinity. The difference between that and restrictions to the domain. If it's restrictions to the domain, you just say x does not equal 1/2. But if it says the domain, you state the entire domain. Next one. Replace g of x with y, swap x and y. X is 2 root of y minus 1. Square both sides. X squared is now... Okay, y'all know that you can divide by 2 and then square both sides, or you can square both sides and then divide by 2, like same difference? Okay, because it's just going to be 4 times y minus 1. Right? Square outside, square inside. So the order doesn't matter. I'm still going to divide by the 4. Hey, get back here. I said green. I'm going to have x squared over 4, so whether I divided and then squared or squared and then divide, same thing. That gets rid of this part, then I'll have to add 1. So my function, or my inverse function, is either x squared over 4 plus 1 or 1/4 x squared plus 1. Right? Same difference? I was actually just doing problems like that with algebra half yesterday. And the domain. Well, if I was looking at only the end product, I'd say it's a quadratic, all real numbers. But if the original has a domain of 1 to infinity and a range of 0 to infinity, when I swap domain and range for my inverse, that means the domain is 0 to infinity because, yes, you can take the square root of 0. So, what I'm going to go with is, did you get the correct inverse, the correct inverse, the correct domain, the correct domain? Do you got the work to back it up? Which also means, naturally, if you goofed the work, it's going to domino affect everything else. Do you still do the thing correctly based off of incorrect information? Yes.
So if you put a 0 into there, then would 0 minus 1 be negative 1? And then...
No. Into here.
Oh, so that first part doesn't...
This is the range. Range is saying what is allowed to come out of the function. What chickens do you throw in? What nuggets come out?
It's because when you find the inverse expression.
Yep. Swappity swap. Is there?
So for the second problem with g of x, I did x squared. When we squared both, I also distributed the 4. So 4y minus 4. And then
But then you would add 4 and then divide by 4.
yes, I just
Yeah.
Is that alright?
Yeah. That's fine. You still follow math law. You just got over to Walmart by going through Deadwood. Like,
Gotcha.
all right. Okay, who did that when they first got their license? Like, your parents say, hey, I need you to go pick up some milk, but they didn't specify. So you kind of took the long way. And then Montana? No. Yeah, so it was a minimum of a half hour to get anywhere because we were in nowhere, so. All right. I had a single question on the homework.
Oh, I have a question.
Wait, no, I take that back. 1, 2, 3. I had 3 from you guys. It's almost like someone was listening yesterday. We had 3 questions. Uh-huh. I would answer at 5:45. What do we got? I don't know what that is. Suppose I should actually have this brought up. I keep forgetting. You. Poke.
Now, I'm gonna be honest, I went on the answer one for 36 and it made a lot more sense.
You mean the solutions helped you to do the assignment?
Yes. It
Man, if only those were provided for you for that exact reason. I want you to use the solutions. I want you to look. Because how many times have you been in the middle of a problem and I don't know what, but you look at the solution, you look at someone else do it, and it just nudges you down the right path.
Yes, that's what happened.
Come on, you. Hurry up. There we go. Womp. Okay, uno. 7. Come on. What number? 58?
So I had a hard time with, I think 58. And your 61 probably. Because I don't have a.
Okay, 58. Restrict the domain so the resulting function is 1-to-1, meaning it will have an inverse. It doesn't pass a horizontal line test, correct? Doesn't pass, it doesn't pass, it doesn't pass, it doesn't pass, it doesn't pass. Hey, now it passes. Right at that point. The problem is it's on both sides, right? So, restrict the domain such that x is greater than or equal to -5. Because if I only look there, this doesn't exist.
Gotcha.
Now it passes a horizontal line test.
But then it said to find the inverse of the function.
Mm-hmm.
And that kind of confused me. This is absolute value, and I wasn't sure.
Okay.
So you need the absolute value around the +5.
Cool so far?
Yeah.
What do you think? What has an absolute value on it right now?
5 is 5.
Okay. Which means I will take an absolute value of the output, right? So absolute value, the entire function. To absolute value, the output, right? If I absolute value the whole thing, that absolute values the output. Because the whole thing gets me the output. Yeah. And then -5. It goes back to, remember when it was, do I negate f of x versus do I negate just x? Am I reflecting my inputs or am I reflecting the output? Am I absolute valuing the whole function or am I absolute valuing my input? Okay. Same deal. I suppose. We didn't explicitly say that, and now that I think about it, I don't know if we ever did that in Algebra 2. I don't think we do. So that part was new. Good question. Okay, what else?
36.
Mm. 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 36. Oh no, fractions! Okay. I'll do the first part of it. I'm not going to do the second part because it's the same thing. If I say f of a thing, I'm supposed to take a thing minus 6 over a thing plus 2. That thing is going to be all of g of x, which is 2x plus 6 over 1 minus x, 2x plus 6 over 1 minus x. Let's head all the way back to Algebra 1. Y'all remember common denominators? I mean, if it's like 3/4 plus 5/12, you're okay doing that. It's the same thing, just uglier. This is over 1, take it times 1 minus x over 1 minus x. This is over 1, take it times 1 minus x over 1 minus x. Come on. So now I distribute 6 in here. This is 2x plus 6 minus 6 plus 6x all over 1 minus x, because now they have the same denominator. This is 2x plus 6 plus 2 minus 2x all over 1 minus x. You're like, what is this madness? It's so gross. Dividing by fractions is easy as pie. So if I take this times 1 minus x over all this junk, what? Oh, yes. It's extremely positive. It's feeling good today. Okay, what you end up with is 2x and 6x is 8x, 6 minus 6 cancels, over 1 minus x, times, flip it, 1 minus x over, well, I get 6 plus 2 is 8, 2x minus 2x cancels, that's just 8, and then womp, 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 womp. You need to get common denominators to make it work, though. It's been a long time since rational functions. This is why Mr. Spear and I have been talking for a couple years now. We are moving rational functions from Algebra 1 up into Algebra 2. Because it's the toughest thing in Algebra 1. It's usually where kids nosedive. And then there's a 2 or 3 year gap between seeing it there and either an ACT or PreCalc. Like, it's not hard. It's just been so long since we've had to do the common denominator thing with rational expressions. So we are moving that up as of this year. So, okay, besides EU fractions, anything else? Can we do 21 because we had a moment? Sounds like a country song. Okay, determine whether it has an inverse. If it does, find the inverse. Okay?
It does have an inverse.
It does, yep. So
Can you graph that in your head?
it's rational, so you're going to have inverse. Haven't seen one with a radical on denominator for a while, so it says 8 only exists less than 8. So it's a asymptote that's... Does it only go this way?
No, the other way.
Other way? Oh, okay. Oh well. It's been a long time since I've seen that. You get rid of the radical and it's easy. You add the radical and it sucks. Replace f of x with y, swap x and y. I now have x is 6 over square root of 8 minus x. Y. All right. I'll make things a lot easier here. Instead of cross multiplying, y'all remember something from geometry called means and extremes.
I remember talking about it, but I don't remember doing it.
A over B equals C over D.
Wait, can we cross multiply?
We're going to do it faster than that. If I cross multiply right now, I get BC equals AD, correct? The means are the things in the middle of I'm, working my way through this snake here. The extremes are the things at the beginning and end of that particular snake. I can swap means and extremes at any given time. I can say D over B is C over A. I can swap the extremes. Because when I cross multiply, look at what the products are. Still BC and AD. A times D, still A times D. They are still an equivalent proportion. That means instead of going through the process of cross multiply and divide, I'm just going to swap those two. Swap.
Okay, but if you did it the other way.
But if you did it inefficiently, how would you do it? You cross multiply, getting 6 is x times square root of 8 minus y. Well, I want the y by itself, so I'm going to have to divide by x, aren't I?
Oh, I did it really fast.
Okay.
Like, I did it way worse than that even.
Oh.
Because I tried
Oh.
to.
Well, you can square both sides right now.
I did.
You'd have x squared is 36 over 8 minus y. You can still swap extremes right now. Getting 8 minus y is 36 over x squared, because that's the same as squaring both sides right now.
Oh, you went back to the top question.
Yep.
Whoa, where are we at?
Yeah. You can always swap means and extremes. That's just the property of proportions.
That just made it so much easier.
Yes, it does. And then square both sides. 8 minus y is 36 over x. Move that over there. Y is 8 minus 36 over x squared.
Do you not need to square the... Yeah.
Squared. Missed the squared. Yep.
I was just about to say it.
Shoulda, woulda, coulda. You only get one out of me.
It's only the beginning of class.
That's true. So, that whole means and extremes thing, you use that back in geometry with similar right triangles. Maybe another way to say it would be, y'all remember,
That's how I draw trees.
okay, you have two triangles here, right? If you have the height of the tree to the tree's shadow, what the hell? Versus the height of stick figure Steve to stick figure Steve's shadow. The way that we ran the proportions, I could say the height of the tree compares to the height of Steve. as the shadow of the tree is to the shadow of Steve. Height is to height as shadow is to shadow. But couldn't I also say the height of the tree is to the shadow of the tree as the height of Steve is to the shadow of Steve? Didn't I just swap my means? Height is to height as shadow is to shadow versus height is to its shadow as height is to its shadow. As long as you're comparing the same thing both times, you're good. And that's where we started to develop the whole means and extremes philosophy, that you can just swap them. And sometimes it makes algebra a lot easier. So, any others? Why are you not showing up? Oh, there we go. That's why. They got this new update thing where Chrome has, like, it opens with a person profile, so it opens a person window instead of just Chrome. Oh, it's weird. Yep, so it just opened a blank window, or it's asking me for a profile on the other screen. So, 2-1. We got the packets yesterday because I thought we were going to get further. We didn't, so here we go. What? Yeah? Monomial. What's it mean? One what? One term. Y'all heard binomial nomenclature? Y'all been through biology, right? Binomial nomenclature. Binomial, two names. Nomenclature, the process of naming. I shall name things with two names. Or I shall name it with two terms. Like Homo sapiens. Okay? Like Canis Major. Or is it Canis or Canis? I don't know. Big dog. We have this idea of, we use Latin for stuff because Latin's a dead language, meaning it's not actively spoken by any culture, so its meaning isn't going to change. For example, if I say pog versus you say pog, those mean two very different things. One of you, euphemism for this is cool, this is great, awesome, whatever, acceptable. Yes.
That's so dumb.
Yes. Versus I say pog and it means literally a cardboard circle that you used to put in stacks and have cool pictures on them, and you would slam your pog slammer on it and it was a game. Better than that, it's been my fidget since I was 12. It's a pog slammer. You'd get a stack of pogs and you would do that on top of it and it would, and everything that fell off you'd put in your pile. Because it's got a little dimple on the bottom. I also use this to screw with my freshmen when I say heads or tails, because it always comes up tails. That's how I make the kid that I want to go next. So, anyway, monomials, one term. Meaning it's going to have the form ax to the n. So this is 5x to the third. This is negative 12x to the 20th. This is 6x to the 1/2. Okay. Now this specifically says n is an integer. Once you start putting rational exponents up there, now they're power functions. We're going to get to that in a minute. But a monomial is just one term. The way that we learn these, you probably saw back in Algebra 2, was the end behavior chart that says if A is positive versus A is negative. Oh wait, I got this backwards. If I have n is even versus n is odd, it's just always going to do that stuff. Okay? You notice everything on that list. That was all the beginning of chapter 1. You analyze the living crap out of functions. We teach you how to. And now we're just going to keep throwing different types of functions at you, and you can tell me stuff about it. If I gave you this graph, you should be able to tell me the domain is all real numbers. The x and y intercepts are both at 0. The range is, in this case, from negative infinity to 0. The analysis part? The analysis part is used for reasonable restrictions to functions. For example, I'm making a function and it happens to be like that, but it turns out I can only have a restriction of the domain from here to here because it's not feasible to go negative. If you understand the concepts of the function, or the details and the characteristics of the function, you can restrict it to the area that it actually makes sense in the real world. Otherwise, you get someone who decides to turn left because their GPS told them to turn left, and they go down a friggin' approach and end up in a mile road that has 0 maintenance, and they're stuck. And then you got to go get the tractor, and you got to go yank them out of the, tow them out, and then you charge them $200 because you say, look, it's going to cost you $500 for a tow truck to get out here and bring you out, or you can pay me $200 to just get you out now because you listened to your GPS because it said to turn left, and you're an idiot. You have to know what reasonable is, and we can do that mathematically so that when it's a real world context, we don't make dumb mistakes. Yeah, but when you have to do it so many times, you get real tired of it. So, but symmetry, intervals of increase and decrease, end behavior, all this stuff that we did last chapter, I can do it with these functions now. The catch is with monomials, if I just know what the leading coefficient is, positive or negative, and whether it's even or odd for an exponent, I know it's going to do this stuff. You all know that evens always start and end at the same spot, positive or negative infinity, whereas odds always go opposite. And then you start getting like the math stick figure dances, you know, cubic, right? I used to have that shirt and then I burnt a hole in it. I like fire. So, analyze monomial. I think you know how to do this. It's just a matter of a little bit of practice. I would like you to use a I'll shorthand it. Okay, x to the fourth. You know how we use perfect square steps for parabolas? I can also use cubes for cubes. I can use fourths for fourths, and so on. So if I got this function, I start with a vertex at 0, 0, and then I use perfect fourths, not squares. So from the right, 1 to the fourth is 1. 2 to the fourth is 16. Womp. But because I have 1/2, what does that do to it? This is why we did all that transformation stuff, right? I cut all of those perfect fourths down in half. So over 1 up a half. Over 1 up a half. Over 2 up, not 16, 8. Over 2 up 8. Over 3 up, 3 to the fourth. 3 to the fourth, not 4 to the third. 3 to the fourth, not 4 to the third. 81. You got 4 3s. 3 times 3 is 9. 3 times 3 is 9. 9 times 9 is 81. but over 2, well, it's still 40.5. It's still way off. So I'm just going to womp like that. If I say negative x to the 7th, well, it's got a negative in front of it. It's going to have that vertical reflection. So I'm still going to have an inflection point in the middle. I'm still going to say 1 to the 7th is 1, but it gets negated. But now 2 to the 7th. $128. Can you do your powers of 2? Like 2, 4, 8, 16, 32, 64, 128, 256, 512, 1024, 2048. Who played that game? Right? What was it? Like 2048 or 4096? 2048? Okay. Yeah. So, that's where most kids nowadays actually know their powers of 2 from, is because they played that game. But anyway, I'm going to go right 2 and down 120 freaking 8. This gets really big really fast, so it does that. Now I need to say what they actually are in terms of all this stuff that it asks for. So, here we go. Domain, range. Frank is cross-eyed. It was writing about a ½ an inch above where I actually put the pen. Bother me. X-intercept, y-intercept, end behavior, so I'll say limit of my function as x approaches. Limit of my function as x approaches. Never mind, I'm going to do 2 of them. Limit of my function as x approaches. What else? Continuity and increase, decrease. Okay, why did I do 2 of them? Well, homework hack. A, B. Okay? So I don't have to write all that stuff more than once. I just turn it into a table. So for part A, that one, domain. We don't have to do tests anymore. You can just say it. What's the domain of 1/2 x to the 4th? All real numbers, because I don't have any of those things that are going to break math law. So negative infinity to positive infinity. Range. Come on, man. 0 to infinity with a bracket. X and Y intercepts. 0, 0 for both of them. So I'll just cheat and do this. Limit of my function as I approach, the end behavior are going to be the ends of its domain. Negative and positive infinity on an even function, they are both going to go to positive infinity. Continuity. Continuous where? Okay, you have to actually say it is continuous at negative infinity to infinity. You have to say along what interval is it actually continuous. Because remember, there's functions that don't cover all real numbers. Say you have a square root function. It would be continuous for its domain, which might be 0 to infinity. Intervals of increase and decrease, it increases here, it decreases there. So increase from 0 to infinity, decrease from negative infinity to 0. Say all the same stuff about B. Well, it's same, 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 but negative infinity is infinity. But now as we go to positive infinity, it's negative because odd functions alternate. Continuous along all real numbers. It is never increasing. It is always decreasing. I should be able to look at any function and just say the stuff because we spent the time going over how to analyze the functions. Okay. Now, a cheater way to get by this is I did not have to do any of that. In fact, as long as I had my graph to do the graph part, the analysis of it is A, positive or negative? Is N odd or even? So, there. That's your answer. Because positive, even monomials do this. Ta-da! So, go down to the bottom, and if I asked you to do 1b, I would cheat my way through it and say, (1b) negative 2/3 x to the what? 5th? That looks like a negative odd monomial. That stuff. So just go to it and say, like, D, that stuff. There you go. I'm not going to make you write it again. It's just so you understand this is what they do. Okay, regardless of what A and N are, they're going to have these properties when they're monomials. When you start getting into binomials, trinomials, once the polynomial starts getting big, okay, now we got problems. Now it's going to have issues.
So we can just put A next to B.
Yep. Yep. Okay. So you get this idea that I can analyze any function and then it's going to do stuff. I would like for you, if you would please, graph this one right here and tell me all that stuff. You graph that and tell me all of that stuff about it. Not this time, because now the exponents are negative. So it's not going to follow those rules. They changed up what the parent function is. So it won't follow those parent function rules. Okay, good chunk you know how that works. Change the parent function, new rules. Go to mom's house, different rules. That's modern America. It's our completionist society. It's this idea that you're supposed to check the boxes. Go to high school, get decent grades, go to college, check. Once you're at college, meet someone, check. Graduate from college, get married, check. Now you're married, go have kids, check. Like that's just, people have this idea that they're supposed to do that, so they rush into relationships before they're actually mature enough to sustain the relationship. Conversational tangents. It happens. Mm-hmm.
All we do is literally just grab like this. Which is, oh, it's over x to the fifth.
And welcome back.
makes it so much easier.
Oh, I actually was smarter than Andrew for a second.
Just X
Well, listen. It's so sad because I was learning to get six.
And then, approaches you.
No, you just gotta figure out.
You don't have to do tests now, though. You can just say it. Well, isn't that how you did it in geometry? You had to prove a whole bunch of theorems, but once you had the theorem, you could just say theorem.
Oh, I failed that part. I don't remember. I was awful.
Yeah. Well, the first half of the class was supposed to be the heavy proof anyway. First half is supposed to be heavy proof. Second is supposed to be a little bit of proof, and then you hit hard the three-dimensional figures.
No, we did not. We didn't do proofs till second semester, right before we went home for COVID.
You want to know what we did before that? We prepared things for the little first graders.
Yeah.
And that was it. We focused all our time on that.
Withholding comment, are you done? What was it, negative fifth?
Oh, yeah.
Which is just negative 3 over 4x to the fifth. Negative exponents. Rule number 5. From Algebra 1.
I remember that.
Rule number 5, negative exponents say flip the switch. If it's numerator, it goes to denominator. If it's denominator, it goes to numerator. Okay? Which means it's just a rational function. Rational functions have that split in the middle. And because it's x to the fifth, that means the denominator is going to get huge. So you're always cutting it by a bigger and bigger and bigger number. So these are going to be real tight in close to the axes.
So, but they never hit 0? No.
Well, if you don't think that it ever hits 0, try 0. Plug a 0 in there. Can I say y is negative 3 over 4 by 0 to the fifth? Okay, you can't do it, right? I can't divide by 0. Likewise, if I tried to say 0 is negative 3 4x to the fifth, and I cross multiply it, I'm going to get negative 3 is 0. Which means y and x cannot be 0, because I have horizontal and vertical asymptotes at x and y equals 0. So I got all that stuff. Let's see if we can just go verbally. I hope you wrote it, but I just don't want to write null, so we can keep speeding through here. Take a look at this thing. Domain. Everything except 0, parentheses, union. Range. Same thing. I can't have 0. Maybe I do need to write this because I'm just hearing a bunch of muttering. Okay. Domain. From negative infinity to 0, can't touch a span, and 0 to infinity. Range. Same thing. Right? X and Y intercepts. Because it will never equal 0 for both domain and range, it doesn't have X and Y intercepts. What else do we have? End behavior. Limit of my function as x approaches both positive and negative infinity. Close to 0, right? It approaches a value instead of infinite. Because if I divide something by an increasingly large number, it's practically 0. What else? Intervals of increase and decrease. Where is your pencil as you go left to right? Where is your pencil heading up? Isn't it heading up and still heading up? So it is increasing from negative infinity to 0 and from 0 to infinity. It is never decreasing. What are other continuity? There you go. And you say its continuity is infinite discontinuity at x0. So either you say continuous for the domain, or you identify the points of discontinuity. Symmetry? I'm asking for that. Remember the symmetry test? Origin, right? Because if it's symmetric to the origin, I should be able to take my paper and 180 it, and it's the same picture. All right. So the idea is I can take any function, and once I got the graph of it, once I have the equation of it, I know how to analyze it. Right? Oh, by the way, because this one is monomials, you can make another chart just like this. It'll be the same thing, it's just it changes for reciprocal functions. Just like you can do the same thing for rational functions, or rational exponents, I should say. A rational exponent, if you got no idea how to do a rational exponent as a graph, how can you graph anything? Table. Graph by table. Good thing I don't have to make the table myself anymore, so stop making that noise. Instead, I'm just going to go to the graphing calculator, dump this into Y1, and I'm going to look at the table, plot points. Yes, ma'am? If it's a rational function or a rational exponent, yes, you can. This is the square root of x to the 5th, which means it's going to behave like a square root function. It's just going to be bigger. So instead of like this, it's going to take off faster because of the x to the 5th. This one, negative exponent, so 6 over the 3rd root of x squared. So a cube root of this is always positive. That one's gonna, is that the, like that, I think? I'm fuzzy on that one. So if you're not sure, dump it into a calculator and check. Let's do this one. Because this is just going to be like any square root function, just go there faster. Oh, I didn't even bring up my calculator today. Poke the button, bring the guy over there. There we go. So type it in, look at the graph, get some points. Y is clear 6x to the negative 2/3. Okay, I get to this. I got no idea what it looks like. I go to my graph. Oh, it's the butt cheek. I thought it went the other way. Okay. If I just see this, could I go to my table and start plotting points? right? So I can go to my table and start plotting points. I get that graph on my screen. Start telling me stuff about it. Domain. Right? I can't have over 0 again, so probably not. Negative infinity to 0, union 0 to infinity. What about range?
It would be 0 to infinity.
Because we have f of x is, what was it, 6 over cube root of x squared, right? Like it was x to the negative 2/3?
Yeah.
Okay. So the range. Thou shalt not divide by 0 gets me domain, but what about the range? You say 0 to infinity. If you're not sure, check. Shove a 0 in for y and see what happens. Herbert from what?
Just go like that forever.
Yep.
Oh, okay.
It is from 0 to infinity. Because I can keep dividing by a number that gets bigger and bigger and bigger and bigger, and I'm going to approach 0. But it's never actually going to hit 0 because I can't cut something into 0 pieces. You know? Go ahead, I dare you. Chop this into 0 pieces. Right? Like you could get a belt sander on this and just, well, you got a whole bunch of itty bitty pieces, not 0 pieces.
You can never have 0 pieces.
Right?
Throw it into a block.
Okay, that's subtraction, not division. Now where'd my pen go? All right.
There's no way you could burn it.
No.
That's subtraction.
Wait,
Or
you can't
like
destroy
thermodynamics.
matter.
Law of the conservation of matter.
Can't destroy matter.
Thanks, Paul.
It's turning into something else. So it's technically not subtraction, so it's not.
And Maddie is officially cut off of speaking. So, what about x-intercept?
It's nothing.
Correct. Because 0 is not allowed for both domain and range, it will not have x or y-intercept. What about end behavior? Limit of my function as x approaches, well, same thing both ways, approaches 0. Gets very, very, very close to it. Continuity. Yep, infinite discontinuity at x is 0. I'm going to have that asymptote again. I know it's not there, but how about symmetry?
Like on the Y.
Y-axis. Yep, symmetric to the y-axis. How would I prove that? Negate x. There it is. So it is symmetric to the y-axis. We said continuity. There you go. Increase and decrease. Where is it increasing? As I go left to right across the graph. Right? From negative infinity to 0. Because after 0, it's coming down. So decrease from 0 to infinity. Okay? I can take any function, even if I have no idea how to graph it, plot by table, take a look at the graph, tell me stuff. The first half of the class is heavy analysis of functions and reviewing all the different type of functions under that analysis lens, because that's what gets you ready for calculus. Then chapter 4 is introduction into trig functions, getting you ready for trig. And then 6, 7, and 10 are a grab bag of stuff getting you ready for stats and calculus. So it all depends on what you're planning on taking next. Oh, there's been some misconceptions about classes and what you should take and all of that. And I really wish that the non-math teachers would actually ask the math teachers when it comes time for registration. If you get a B or better in here, don't ever take college algebra. It's a giant waste of time and money. You're going to test out of it. Okay? Just don't. It's a waste of time and money. If you go from here into trig and calc, which is what a lot of kids do, they either quit at pre-calc because they have their fourth math for that scholarship, or they just keep going. If you run all the way through trig and calc, like, okay, we got mostly juniors here. Who signed up for trig next semester? Good chunk of you? Okay. So, say you take calc your senior year, maybe you do it first year or first semester. You're like, what do I do second semester? You can take Calc 1 dual credit for the Easy A because you've already done that. Who's humming? No, it's vibrate. But so just and tell other kids who are in other classes and they're looking at what do I want to do for next year. Y'all, you need Algebra 2 if you want to go to a 4-year university. If you want the Regent Scholarship or South Dakota Opportunity Scholarship, you need 4 years of math after from Algebra 1 and beyond. So it'd be Algebra 1, Geometry, Algebra 2, and either PreCalc or College Algebra and Stats, dual credit. Okay? So either both of those or PreCalc. After that, it just depends on what you want to do with your life. If you're heading into a STEM field, go take trig and calc. If you're not heading into a STEM field, it's a waste of time. Like, I'm the math teacher, and I'll tell you that's a waste of time. Yeah?
So one like me would help 2 and 3 be a waste of time.
Where are you going? Well, no. If you're going into a STEM field, you're going to want to do through calc here. If you have the opportunity to do dual credit, calc 2, calc 3, diffie-q, differential equations. What is it? Non-Euclidean geometry, college trig, which is more proofs, and then you get into foundations, which is all proof, and discrete math and ring theory, which is all proof. After a certain point, it stops being math and it's just prove things. But yes, you will have to do that.
If you take calculus, are all of them just kind of dumped in fake, or might as well test that?
Again, depends what you want to do with your life. If you're headed STEM, take as much math as you can. Keep running it through.
I want to be a surgeon.
You're going to have to go all the way through diffie-q so that you can do the chem classes. The biomed classes require that. But we did that. Ooh, this one. Graph it, tell me stuff. Or show me thumbs. Like, do you get it? I don't care if you like it. Do you get it? All right, then just cross them out. We'll move on. Okay, power regression. Some of you did not have a whole lot of experience with graphing calculators back in Algebra 2. Do you remember? We reviewed it. Chapter 0, how do you do regression models? Ruh-roh. Everyone got a graphing calculator on hand? Womp. Do you remember how to input data into a table? Where? Stat, edit, start typing. All this stuff is going to go in a table. You're going to put, okay, this is one table. They just split it into 2 levels because it was too long. All the M's in list 1, all the R's in list 2. Okay? It's one long table. And I'll see if I can race you. Right, no, this stays here. I need the calculator. There we go. Womp. Zoom on table. And go. 0.3, 0.4. Oh, wait, I'm on the wrong page. Number lock? Why are you not doing things? There we go. Okay. 4. Uh-oh. 29.8. Right? Okay. Okay. I think we're good. Right? Alright, unless I did fat finger something. I should be good to go.
Okay, so when I do the two variable stats for like do I just, since I have both, so I just click enter again, or if it's just like.
But we're not going to do two variable stats. Two variable stats compares statistical value between the two. I want a graph. Okay, so we're racing ahead here. Just, does everyone got the stuff? Okay, I had to back up a couple of times because, like Homer Simpson fingers. All right, once I got a bunch of data, it says make a scatter plot. You remember where scatter plot is on the graphing calculator? Right above y equals is your stat plot. And turn plot one on. Make sure that it's a scatter plot and not one of those other types. Make sure it's the right lists. So, for example, it's really common to have a like double-decker table that says here's the years, here's the temperatures in New York, here's the temperatures in LA. Well, I would want to use list 1, list 2 to do years in New York. I would want to use list 1 and list 3 to do years in LA. Right? So you got to change the list to match whatever you're actually trying to find. Once that plot is on, if I try to graph it, it's, oh yeah, that's still there. No butt cheek. Clear. Okay. If I try to graph, it doesn't show anything. Why not? My window's way off. Take a look at what this graph does. It goes from 0 all the way up to 83 and change. Goes from 0 all the way up to about 2,000. So option 1 is I go to my window and I manually change that. I say I'll go 0 to 100. I know. Fit doesn't always work, right? I can go 0 to 100 going by tens. I can go from 0 to, say, 2,000 going by, I don't know, 200s. Graph there I got them. Option 2, if the stat plot is on, and this is why I didn't start with this. If the stat plot is on, and if you have data in your table, you can just zoom. Option 9 is your statistics. Okay? But if I look at the window, look at where they're going. Up to about 100, up to about 2,000. They're fitting your data in that table. Okay, so yay, I have a graph. That's actually good. That means it's consistent data. Okay, create a scatter plot of the data. Y'all, someone's going to ask this question on the homework. I bet I have a question on there that says create a scatter plot of the data. Make a scatter plot of the data. Do you remember how to make appropriate scales? I've got to fit from 0 to 100 on this, and I see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So, X scale by tens. I see 10 boxes. I've got to go to at least 2,000. Y scale by 200s. Okay? So just make sure that you have appropriate scales. Make sure you label it. Actually make the scatter plot. So you should effectively have that on your screen. Oh, something I don't show lower classes. If I were to change that window back to 0 to 100, going by tens, go from 0 to 2,000, going by 200s. I want you to check out right above zoom is format. I can turn my grid lines on. So now, when I graph it, I actually get the boxes that would be on my, actually on my paper. So I will know exactly where on those boxes without having to count. Okay? It's going to come in real handy if I show you the trick to do that in terms of pi in chapter 4. Okay? It does fun stuff. I mean, you still have to know how to graph the function in order to get that, but it's handy. So, once I got all this, blah, 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 write a polynomial function to model the data set. What is the name of this particular example? Power regression? So, do you remember where all your regression stuff is? Okay, stat over to calculate. All of these reg. Regression. These are all the different types of regression your calculator can do. And we specifically want power regression. Badoop. Do you remember how to store so you don't have to retype it, losing some of the decimal train? Okay. Not bad. If you're on a TI-83 or 4, you can hit variables, the y's, the function y1. If you're on a TI-84, you can alpha trace, brings up your shortcut menu. Okay. All right. I want you all to just watch right up here. We'll see how good your young eyes are. Oh, down there. Okay, I thought it was going to go a lot faster than that. You can actually read it. If you're on a TI-83, which is the emulator on your laptop, y'all know where that is? I hope, because, you know, you should have used it nonstop last year. If you head all the way down to T, you get TI-83 plus Flash Debugger. Boy, that's a name. When you poke to that, it's going to bring up a, whoa.
How did you have 84?
Because I put in a purchase order a couple of years ago to get a emulator for all math teachers. Oh, if you have a personal computer at home, not your school PC, because you can't download executable files, or you can't actually run them. If you have a personal computer at home, just Google search for TI-84 TI-84 plus free emulator, and TI does a 90-day free trial of this that I use in class. So it's free. Also, I think I said on day one, who here has got iPhone? Sucks to suck. The Calculate 84 or equivalent will only do linear regression. It won't do anything else. Who's got Android? Free. You get the actual TI-84 emulator for free on yours. It's called Wabbit, like Elmer Fudd, Wabbit, W-A-B-B-I-T, and it is legit a free TI-84 on your phone. So, but anyway, you do this Flash debugger, you have to hit New. You choose your model, don't choose the 73, that was old when I was in school. 83 Plus and 83 Plus Silver, this is just a different skin. And you have to hit play, and it's all the way over here. Suppose I should turn this off. There you go. Okay, so the TI-84 is on your laptop. You do have access to it. Don't point, click to do the buttons. Just drag it over to the side of your screen and hold the screen like the calculator's in your hand. It's faster. But everyone has this on their laptop, so everyone can do the thing. But the reason I talked about that is because TI-84s have that cool little pop-up menu that says, hey, what list do you want to use? Do you want to store this? Do you want to have a frequency table? On a TI-83, you would choose power regression, and then you'd say list 1, comma, list 2, comma, Y1. To say use list 1, use list 2, put it in Y1. It should. Now it defaults to list 1 and 2. You don't have to put that part. But if you just do power reg Y1, it will go in. We did a goof? Oh, okay. Is this what you got? I just want to make sure that I press the buttons right. Okay. Now, the store feature means I don't have to write it down. I don't have to retype it in Y1, because now if I go to Y1, it's already there for me. So when I graph, there it is. Okay. Which allows me to answer questions that, and state the correlation coefficient. Correlation coefficient is the fit of it. And when I did my stat calculate my power regression, there we go. You see that when I found the equation, it didn't give me a correlation coefficient, an R2 value. It didn't say how good of a fit this was. If you're on TI-84, you get to just nicely go to mode, and you turn your stat diagnostics on. That's it. Now when you run the regression, it'll give you that correlation coefficient. Every time you reset your calculator, it defaults to off. If you're on 83, you have to, all the way down here above 0 is catalog. You got to go into the catalog. You don't want to scroll all the way to the D's because the catalog is everything your calculator can do. So instead, right above the reciprocal button is D. I'm just going to poke that to jump down to the D's. And there we go. Diagnostics on. Okay, if I do this when I calculate that regression, see how much faster Frank is now? Now it's going to give me those values. We always use R2, R squared. Here your R-squared value, your coefficient says that this is a 99% fit. This model fits my data with a 99% fit. This is a tailored suit. This is perfect. Okay? This is rich people getting clothes for the red carpet fit. Okay? So. All right. Okay, not like Met Gala style. Like that's some.
She literally looked like a dimension of Harry Potter.
I don't. It's rich people saying, "Look, I'm not crazy. I'm eccentric."
Actually, they get sponsored.
Same thing.
It raises money for like.
Yes. Rich people say, "Look at me. I'm rich and famous, so I can do really stupid things, and you praise me for it." Whereas if I were to show up in a butterfly suit to school, people would look at me weird. Yeah. But anyway, write the polynomial. We wrote it down. Round the coefficient. Don't ever do what they. Oh yeah, thousandths works. Correlation coefficient is a 99% fit. Blah blah blah. You should have done this a lot. Did you write down the that? Did you write down the R coefficient was 0.99? That's it. Like it, all the work is done on the calculator. Okay? All the work is done on the calculator.
So we only have to write down the R2.
So you would have the y is whatever x to the whatever that was. And next to it you would say your R coefficient was 0.991, I think.
Oh, got it.
Meaning it was a 99% fit. It was almost perfect. If you do a regression model and you end up with something below 95%, it's not the greatest. You're down in the 70s and 80s, it's trash. Okay? And then if you could actually do the scatter plot, would you be okay going 0 to 100 and actually stating what M is? Is your metabolic rate? Or no, that was R. It was your rate. Okay, could you actually make the scatter plot? Let the calculator do all the work for you, but make the scatter plot. Radical functions, and then, oh yeah, you haven't. Okay, that is day 2. Yeah, we'll cut it off there. And in fact, because this was all analysis, you know what? I will. Normally, I don't have an assignment here. I'm going to make a small one, like 1 or 2 analysis problems and 1 regression, just to make sure we know how to do regression on our calculators. Okay. If I don't send it because I'm going to forget this conversation in another 2 minutes, I also have a old, like less than 10-minute video showing linear regression for Algebra 1. It's all the same stuff, just poke power regression instead. Okay.
So just wait for text or second time.
Oh, let me just go through it right now. Maroon Days, I got prep next.